Now we're talking about linear velocity, and it's the distance the point travels along its circular path per unit of time. And the equation is v equals a over t, where a is angular velocity and t is time.
Okay, so this is an example of angular velocity. So we have this given, which the record rotates at 33 and a third revolutions per minute. And we have to put that into radians per second. So since this is already an angular velocity, since it's revolutions per unit of time, we just have to change it to the correct units. So the way you do that is W, which represents angular velocity, is equal to 33 and a third revolutions over minute, to represent the per minute over here, and then you multiply that by 2 pi radians over revolutions, so that the revolutions cancel out each other, and then you multiply that again by 1 minute over 60 seconds. And that will get you to 1 1/9 radians, which is what the angular velocity is in radians per second.
Hello, we're here to talk to you today about angular versus linear velocity. Angular velocity is the number of degrees through which the point turns per unit of time, and the equation is W equals theta over t, in which t represents time.
An example of linear velocity is this. So we have to find the linear velocity of this record per second, where the needle is located 14.5 centimeters from the center. So the way you do that is you use an equation that's given to you in the book, which is V is equal to RW. So that is equal to 14.5 centimeters, which is this right here, over radians times 1 1/9 pi radians over seconds. And we got that from finding the angular velocity in the last problem. And then if you do the math for that, you get that equal to 50.6145 ... So that is equal to about 50.6 centimeters per second, which is the linear velocity.